Okay, I think we are here. Good morning. What we're going to do today is we're going to look a little bit more at manual mesh leveling, a little bit more of the details of that and how to activate it in other firmware. We're going to look at Marlin, the plain version of Marlin. Today, we're also going to change the nozzle out on our, hopefully we're going to change the nozzle out on our printer. I want to print some of the material that's a little bit abrasive. Like I wanted to try this stuff from last time. We looked at this EPA. I finally figured out that PA is polyamide, so it should be nylon. Now it's ePA, so I don't know if it's this is from eSUN, so I don't know if it's some special blend. Probably it is because it prints at a pretty low temperature for what a lot of the other nylon prints at. So we'll see how it actually works, or we'll try to see how it actually works. I didn't actually print anything with it, but we're going to try. But it did say consider a hardened nozzle for this one because this one is glass fiber reinforced. I looked on their website, and maybe this is a new product that's not quite out yet because I couldn't find this one. I found a similar thing, but instead of glass fiber, it was carbon fiber reinforced, and they do have that for sale, but this one's glass fiber reinforced. So we're going to see what it does for printing. We'll do that towards the end. Hopefully I don't break the printer so that we can't try that out, but we'll see. We'll see what happens. First, I wanted to do a little bit of, last time we installed the TH3D unified firmware, which was pretty simple. Well, it was pretty simple on the stream. For me, it actually took a while, but it had nothing to do with the firmware. It was just the SD card and interfacing with the motherboard here. It didn't like having other files on the SD card. It just wouldn't update with other files on the SD card for whatever reason. So I just erased, or actually I formatted the SD card, and now it seems to work fine with other files on there. But we'll see if that holds true for today. But anyway, we used the unified firmware from TH3D, and I wanted to look at how do you do this if you just want Marlin, because I did run into one thing that was, it's not a big deal, but we were doing the manual mesh leveling, so our printer doesn't have any sort of sensor on it, at least not yet. And so I wanted to take into account the fact that the bed could be warped or wavy or something like that, and I wanted to adjust for that, and that is called manual mesh bed leveling, or some combination of words that are similar to that. It's mesh and manual in there. It's not automatic. And so what we needed to do is install that option, which we did, and we ran it, and it does a 3x3 grid, so it goes in and probes 3x3 points on the grid, and that makes a really coarse mesh. So I wanted more points, and I couldn't figure out in the TH3D unified firmware, I couldn't figure out where I could set the number of grid points. Maybe if somebody has done that and it's possible, you can show me, but I know how to do it in Marlin, and I figured that some people might want to just use the Marlin builds anyway. So I was going to go through and how can we do the same thing but use Marlin? So we need to get Marlin, which if you go to Marlin well, let's start at the beginning. marlinfirmware.org is the web page for it, marlinfw.org, and that gets you here. This is also where you can find the G-code references for Marlin, is on the same page. I think we talked about that once. Download 2.0.8.2, apparently that's the most recent stable version. And there's two sets here. There's the download Marlin, and there's the Marlin nightly builds, are called the bug fixes sometimes. So the releases are up here, and they're probably fine. I tend to use the bug fix. They seem to have the most up-to-date set of little bugs tracked down and squished. So they would be slightly newer versions of the actual release version. So they're a little bit more recent. And if a common bug has popped up, they are probably going to have it fixed in these. So I've downloaded this bugfix 2.0.x.zip, and you also need these configuration files. So it works a little bit differently than the unified firmware. So when we downloaded that one, you had to go through and find the printer model, or at least brand, and then you took that file and they had it broken out that way. This Marlin does it slightly different. They have one version of Marlin, and then they have hundreds of configuration files, and you put the two together. So I downloaded both of these. They're zip files, and I extracted them. Then we can go over to Visual Studio. We still need Visual Studio. I did add one what is it called? Extension. I did add one extension. So in this little 4 blocks, with one of them, it's, you know, where your plugins are basically. I have, well, I think the C++ is just there automatically. You would need Platform IO, the IDE for that, and you would already have installed that if you did any of the firmware with the TH3D. But I also added Auto Build Marlin. It just makes it a little bit simpler to build. When you go to compile the firmware, it makes it a little bit simpler. You don't have to search through a bunch of lists to find the right piece of hardware that you're trying to install to. It goes through your firmware and finds what you're planning on installing to, and puts it together for you. So when you want to install an extension, you just type in the one you're looking for, Auto Build, and then it'll start filling in options. It may not, yeah, there it is, Auto Build Marlin, and you just, normally they would have an install button. Mine has a configure button because I've already installed it, or manage is what they call it here. So we do that, and we need to open a folder. So we will open folder. Let's see, this, I put it on the desktop. Here it is, Marlin Bug Fix 2.0. Another Marlin Bug Fix 2.0. This is the one that we need to open. There's Marlin sitting there, and we don't want to actually go into the Marlin folder. We want the folder that Marlin is in. So we select that folder. It'll probably open. Yes, I do trust these authors. So to open that folder, here you can see over here, it opens the Platform IO initialization file. This is what you would have to edit without the Marlin auto build. You'd have to go in and edit this thing to pick out the right environment that you're going to use. But if I go to auto build Marlin, it should say, yes, it says Marlin Firmware 2 whatever is open in the workspace. So as long as it says that, then you're okay, and you'll be able to build right here with the little hammer. All right, let's go back to our, oh, you know what? Let's close the folder. Hold on. Close folder. I just got through saying you have to put these two things together, and I didn't do that. So what we need to do is we need to open the actual folders, Marlin Bug Fix and the configurations bug fix. So let's open the configurations first. And there's a little README here that kind of tells you what to do, but let's go in config, and let's go to examples. And here you can see all the different printers you have examples for. We want the Creality, so here we go. And then there's a bunch of Creality printers. We want, ours is the plain Ender 3, so it's not the Max or the Pro or the version 2. We want the plain Ender 3. And then there are all these different boards that you might, the control boards that you might have on the Ender 3. We want the 4.2.2. We looked at our board and that was the number on the board, so we want that. And inside there, you have, normally you'll have at least these two, configuration.h and configuration advanced.h. You might have boot and status screens also. If you do, that's fine. You copy these files. So we're going to take these and we're going to put them in. Here's the Marlin itself. So open Marlin, and then there's configuration and configuration advanced. It doesn't have any boot screens showing up in here, but that's okay. We're going to take the example ones and just put them over here. And we're going to replace the existing configuration in configuration.h. So, and I did copy over the boot screen and status screen. All right, that process, taking those example files, I might not should have removed them from here. I probably should have copied them from here, but it's fine. We can always download new ones if we want to. And now I don't need the configuration folder anymore. I could dump that if I wanted to. But now I have configured Marlin to work with the Creality Ender 3, at least the base version. You know, it gives this dimension of the bed. It has the base, you know, values for E steps and X, Y, and Z steps, and how to heat the hot end, how to heat the bed, the thermistors that it uses. It uses all the default configurations. Some of those you might want to change. Maybe you change one of these things, then you need to go change that configuration. So we could work with this, but it doesn't have the things enabled that we wanted enabled. So we're going to, we'll close this. Now let's open a folder with Marlin, and it'll have these new configuration files. So Marlin bug fix, there's Marlin. Select folder. We will check to be sure that it opened. Yes, it's open in the workspace, so that's good. We don't need the platform IO thing. What we need is we need to go into the Marlin folder. So here's Marlin, and inside there's the boot screen, status screen, configuration advanced, configuration.h. So we need to edit the configuration.h file. And there's a couple of things. What I want to do, remember I had adjusted my E steps to 97.7. So I want to go ahead and do that. Might as well put that in here so we can just look for steps. Control F is what I type. Oh, look, we can change our machine name so that it's more personal. Let's see if we can find our actual steps now. Here they are. Define default axis steps per unit, 80, 80, and 400. That's for X, Y, and Z. But here's our E steps, and you can kind of see the order they're in up here at the top. Ours, I've already forgotten. 90. Let's see, where'd it go? 97.7 is what we want for this number. So if you don't change that, it's going to, for Ender 3, it's going to default to 93. And so all the little things that you had done, our PID tuning will be changed. We're overriding all of that stuff. So I don't remember the PID. I didn't write those down. So I'll have to edit those the same way we did before, where we go in and do the PID tune. They should be in here. But I don't know what to put in there for them, so I won't be able to actually change them anyway. Here's the PID tuning. There's oh no, that's in disabling. I don't want to do that. Well, I don't know exactly where the values are stored, and I don't know the values anyway. Here they are for the bed, so they'd be similar to that. I just don't know what the values are, so I'll have to do that one manually later on. We won't do that today. It was pretty straightforward. You just run the PID tune command using a terminal interface. What we want to enable is our mesh bed leveling. So let's look up mesh, and here are, so I just searched for mesh. I'm doing Control F to find, and then you get this little box up here and you can look for different keywords. There's several. There's 5 of these options here. 4 of them have auto something. So those are the ones where you need a sensor. I don't have a sensor, so we're just going to do the bottom one, that's mesh bed leveling. So to activate it, you uncomment it, and then it turns colors, and it's showing that it's actually an active command line. So that turns it on. I also want to use the LCD. I don't want to have to type things in like G-code or whatever, like we did with the PID tuning. I want to use the LCD, so I'm going to look for LCD bed, so LCD underscore bed. And there is a question about if it's enabled, do these things, and right above that you can see where you enable it. So I want to enable that. so that now I can actually use the LCD on the printer to do the process. I don't have to go through the terminal somehow. Another thing I want to restore. Let's see, restore, not that one. Here we go. So normally what happens is G28, the G-code command G28 is home all the axes. And by default, that is going to erase, not erase, it's going to unload your mesh data. So all the heights and everything of the different points that you measured on your bed, it's going to unload those and they won't be active. So we want to restore leveling after G28. Whoops. So that after we do a homing command, we can restore it. Now we can do this in the G code without this command, but this will automatically do it. I'm probably going to put it in the G code to restore, to reload the mesh data anyway, just in case, but this should do that without us having to do that. Now, the thing I was actually trying to do is I wanted to change the grid pattern. And so if I do grid max, well, it is right there. But that's not the one I want. This one's grayed out. So let's find another one. Auto, here it is. So here is the mesh bed leveling routine. So the else if mesh bed leveling is enabled, which is the one we enabled, we can define a few things about the mesh itself. So first of all, how far inset does it go? How close to the edge does it get? So mine is 10 millimeters from the edge of the perimeter of the bed. And there's that default 3x3 grid. Well, actually, this is the 3 in the X direction. And then the next line defines the Y as whatever the X is. So if I put a 3 here, it'll be a 3x3 grid. You could do different patterns. They don't have to be square patterns, but and there are some beds, like I have a TiVo Black Widow that has a really oblong bed, and so it could be that you want more in the X direction and less in the Y direction. In that case, the Y is controlled by this variable right here, which right now is just pulling the value from the X. So you could do X and Y as different values if you wanted to, if you had a rectangular bed. Most printers these days have square beds, but there are some that have rectangular beds for whatever reason. And it technically, the G code for this can go up to 15 by 15. That'd take forever for one thing. But it says don't use more than 7 per axis. Somehow the way that they implemented the routine to actually do the probing is limited to 7. I didn't go read the actual routine on what they're doing, but the G code should allow for 15, but somehow it's stuck at 7. I don't want 7 either. I'm just going to do 5. I wanted a 5 by 5. That gets, for this size bed, that gets a pretty dense set of data. So we change that to 5. Then there are a couple of other things that should be right around in here. I don't see it right now. There's a pattern that you can enable. You can send a one line of G code and it will print a leveling pattern for you. Basically, it's the same one that we started with the squares in the corner in the middle. I don't see that right now, but usually it's around here. I don't want to enable that, but there is that some people like to enable. I just don't see it right now. There is one other thing I want to check on, and that's in the configuration advanced. I didn't talk about this one last time, but it's called baby stepping. And it is enabled. So by default, it's enabled. What this does is, as you're printing, so you've got the thing heated, the bed's heated, the nozzle's heated, and it's printing, and it goes in and maybe you're doing the skirt or the brim or whatever, not the actual model yet. What baby stepping does is you can double click, or sometimes it's a click and then there's a menu for tune as you're printing. And one of them is, it's either called baby stepping on your menu or it's called live Z adjust, so that you can actually turn the knob on the LCD controller and move the nozzle up and down to get it just right off the surface without having to change the bed knob, you know, change the bed level. So this is a good combination with the bed mesh compensation. So the bed mesh compensation, or the thing we just turned on, will go in and trace over the bed, and then I can set the exact right height above the bed using baby stepping. So I do like turning this one on. It's already on by default. It wasn't commented out. Right now it's set to this multiplicator is set to 1, and so it's going to move in thousandths of millimeters. You might want to make that a little bit larger, or well, not necessarily thousandths of millimeters, but really small fractions of millimeters. It's in steps, I guess. So however many millimeters one step is on the z-axis. I will leave that alone for now, although you might want to bump this number up just to not have to turn the knob so many times to get it to do anything. I'll leave it like this for now. Those are pretty much all of the options we need to change to get mesh bed. It's not really leveling. So there actually is a mesh, or well, a bed leveling routine where your bed is actuated. So your bed itself can be moved up and down through stepper motors, and so it can level, move one corner higher and another corner higher. That's actually bed leveling. What we're doing is bed compensation. So we're probing the surface of the bed and then compensating for how it's not perfectly flat. So it's a lot of times I say bed leveling, and I think it even says bed leveling in here, right? Yeah, auto bed leveling, mesh bed leveling. It's not actually leveling the bed. It is compensating for an uneven bed, where there are printers that do an actual bed leveling. They go in and tilt the bed to make it level. We're not actually doing that, and I'm not going to add that to this printer. That would be quite a bit more complicated to do than what we want to do. So now we can go. We've got our changes made. We can go over to the auto build Marlin, and we can click on the little hammer, and it'll use a specific environment for build. So I have these two options here. I'm going to use the top one. I don't want the maple one. I actually don't know what the maple one is, so I'm not going to use it. The other parts of this look correct. It's got the 4.2.2 board. It's got the Ender 3 and STM32 F1. That's correct. This is all correct. I don't know what that maple one is. I'll have to investigate that. But now it's building. Actually, if you look at the bottom, it's downloading some tool that it needs to build this. And that'll happen a lot. Even if you've recently built, there's a chance that it needs to download some kind of tool or environment or whatever to build the thing that you are trying to build. So that will take, again, 2 to 5 minutes to do. In the meantime, let's go over here, not there, over here, and let's look at this nozzle. So I'm going to take the cover off here to get down into the hot end, and we'll see what's going on in there. The printer's off right now. We're actually going to need to turn it on because it is better to change out the nozzle with the nozzle heated up, at least some. And then certainly if you don't put the nozzle back when it's heated, or at least do the final tightening with it heated, then it's going to leak, pretty much guaranteed. So here's what's inside here. First of all, there's this little silicone sock that we have to take off. The nozzle's under here. Maybe I can raise that up a little bit so we can get a better look at it. Okay, let's get down there's the nozzle. Let's see if we can focus on it instead of these other things. He wants to focus on the other things. All right, let's get that out of the way. Still building on the firmware. So the nozzle's down here, and you've got the heat block. This is where that little circle there, the heater cartridge, is inside there. These wires are the heater wires, and bundled inside there is also a thermistor. That thermistor is very fragile. It's on the back side of this. It's very fragile and very easy to break. So we don't want to damage that. Inside here, this little tube, I don't know if you can, yeah, you can kind of see. It's between the heat sink and the heat block. There's a little tube. Uh-oh. Our build failed for some reason. I'm going to rebuild. Sometimes they fail the first time. I'm going to build it again and see if it'll complete the second time. This heat break is keeping the hot heater block from transmitting heat into the heat sink. Because if this part gets hot, and that's also the purpose of this fan up here, is to cool this heat sink. If this part gets hot, then the filament is in here will begin to soften and you'll get jams everywhere. So you need this little gap, but you still need these things to be mechanically connected to each other. And so this heat break is between them, connecting them. This particular one looks like it is held in with a set screw. So there's a little tiny screw right here that's holding it together. Some of them screw together. This one is held with just a set screw. So let's make sure that that's tight, just because we don't want any problems later. Yeah, it's tight. It's plenty tight. Yeah, totally fine. So one thing you might think is, well, we'll just get a wrench on here and undo the nozzle, and you might be able to do that. But these nozzles, if they were put on correctly, what happened is they hand tightened it, and then they heated this up and tightened it another like quarter turn or so to make it very tight so that it doesn't leak here. And probably if you just did this and tried to undo it, you would either shear the nozzle or shear this heat break. Maybe the heat break would just slip on this set screw and kind of scar the surface of the heat break. This would probably turn if this doesn't break, and it might put some stress on your wires over here that you don't want. So what we're going to do is we're going to heat up the nozzle. Maybe not all the, well, we'll heat it to printing temperature. So we can do that with temperature or prepare or whatever. Mine currently says temperature, so I'm going to go to temperature and nozzle and set it to 185. That'll be hot enough. And then we'll go to the info screen to check when it gets up there. Also, just to help make sure that we're not going to pull these wires out, I'm going to hold the block. Now this block is going to start getting very warm, right? So I'm going to also hold the block with some sort of tool. Here I'm going to use a adjustable end wrench. Being careful not to crush the wires on there. I just need something to kind of hold it stationary. Oh, you know what? I think I'm going to have to get a bigger one. This one's just a tiny bit too small. Let me get a bigger one. This one's going to be a little overkill, but it will at least hold our backup. I just want to be able to hold the backup here so that this heat block, which is getting hot, doesn't turn. It's almost up to temperature. We are still compiling. Hopefully we don't fail again. I wonder if it would be better to hold this way. Might be better to hold this way, except it's going to be in the way of my wrench, but I won't be touching any of the wires that way. Oh, you can also use the little wrench that came with your printer. I have a wrench. If I can get it on there, I may have to use the other tool. All right. Once you break it loose, and again, it's not very hard to break loose when it's heated, but if you try to do this while it's cold, then it will be problems. Now, I just realized something. I've still got all the filament in here. I'm going to pull the filament out because I don't want it creating problems. While we're here, I'll actually show you a way to unjam your printer. We can go ahead and turn the temperature off for now, just to let it cool back down some, because it doesn't need to be hot again until we go to set the nozzle back in there. All right, there it is, very hot. And it's got some leftover filament stuck in there, which would probably be good for me to go ahead and pull out, but everything's really hot right now. There's the glob of filament. If I don't get that out now, it's going to be tough to get it out later. When it, or I'll have to heat it up again to get it out later. Ooh, very hot. All right. So this is the nozzle cleaned out. You can I don't know if you can tell that there's a hole all the way through or not, but if you look down, you can actually see that you can see all the way through it. All right, so that, and it's going to be hot for a while, so make sure that you don't put it on something that's going to burn. Here's our replacement guy. Now, when you replace the nozzles, you can replace them with different sizes. All right, our firmware did succeed this time. Sometimes it fails on the first build. Maybe it has to do with the things it had to load. I don't know, it does stuff out of order. But the second time, usually, if you just recompile, if it didn't give you any actual errors, that stuff was missing, it just failed, then just hit build again, and it usually succeeds the second time. I'm not sure the exact reason why it does the failure. Anyway, notice, let's see, is this still hot? It's cooling down enough I can hold it. So we did have a brass nozzle. They're like $1 each or so. Now we've got a hardened steel nozzle. Still not very much. There's a few dollars at that point. You can get these in different sizes. This is the same size. So this is a 0.4 millimeter, where the old one was also 0.4 millimeters for the hole. You can actually get larger ones. I think I bought a volcano or a super volcano, probably just a regular volcano hot end extruder to add to this later, and it's going to have like almost a 1 millimeter nozzle on it. Maybe not quite that size, but 0.8 maybe, so that we can print really fast but coarse. You can also go down. I've seen nozzles, I think you can get them in 0.2, maybe even 0.1 millimeters. If you want to print some really fine details. Now, it takes forever to do, and there is a better way to get fine details on cheap printers using the resin printers that are in the same price range than these guys. They're just messy because they use liquid resin, and we'll look at that later in the quarter. I'm basically trying to let this cool down enough I can get close to it. It's still pretty hot because the fan's not over here cooling things down, right? So it's still pretty warm. If you take all of this apart ever, I was going to show you a way to clear it out. So let's say you get a clog in here. The way these are set up, not every printer is set up this way, but the way these are set up, you can actually force this tube all the way through. So take the little clip off of here, and I don't know if I want to do this because I don't remember how easy this is to release on this printer. I don't know if I've ever tried that. And it could be that it's a pain to release this thing because these are relatively cheap. And but if you have a clog in here, then you can take and force this Bowden tube all the way through. You have to take the nozzle off. Take the nozzle off and then push everything out, and all the filament that's stuck in there, that's leaked out or whatever it's done, will come out the bottom. You do have to make sure you can get the tube back out. So if yours is stuck where you can't actually release it, the way these are supposed to work is, mine's just really hot right now. So you push this thing down and then you can pull. Okay, so it does come out relatively easy. Oh, the fan is going crazy over here. I did notice on this one, this fan is failing already, so sometimes it gets stuck, and I'm going to have to replace it, but for now I'm not going to worry with it. We'll probably replace it with a you can see, we'll put a silent fan, so you can see that it pushed all this. It actually, there was some left in there. You just have to be able to get it back out. So don't put the tube back in until you've put the nozzle in, though. Also, these nozzles do have threads on them, so you do have to get the same type of thread that was on here. I believe these are M8 threads on the Ender 3. Other printers might have different threads. We're going to put this, I think this is still really hot, but we'll try. So we start it. Wow, lost it. All right, we got it started. Oh, what I was saying is, if you ever take this all the way apart, there's like 4 pieces here. There's the nozzle, the heat block, the heat break, and the heat sink. If you ever take all of that apart, be sure you put the nozzle back in first, then set the heat break on top of it, you know, screw it in, or most of them screw into the heat block at least. This one does use a set screw for the heat sink. And then put it back together, and make sure you have a gap between here. This one actually has little standoffs that keep it from getting too close. If this heat block touches the heat sink, you're going to conduct heat up here. Right now we're just radiating heat, and there's a tiny bit of conduction through the heat break, but it's not a lot. But if you touch this block onto the heat sink, it's going to conduct heat in there, and your filament's going to get clogged up in here. All right, so we're about tight. I'm going to tighten it snug, and I'm going to heat it back up. If you just try to hand tighten it, you know, maybe you get the back up on here and hand tighten it, there's a good chance that you will not get it set properly. And if you don't break something, so if you put so much torque on it that you shear the thing off or whatever, then it still could be not tight enough, and you're going to have filament leak either from here, or it might even come out up here, because there's going to be a tiny little gap between the nozzle and the heat break when they heat up. Now, a good thing here with the steel nozzle, you know, we did have brass. So we had brass, aluminum, and these heat breaks can be steel, or they can either, some of them are titanium, usually not on the stock printer, but you can add a titanium one. So they all have different heat expansion rates. But with the steel nozzle, it's going to be less expansive than some of these other materials, and so it's not going to maybe shrink or create a gap as badly. But we still want to get in here and do another like half turn or quarter turn past snug. So I'm going to call that good. Now we need to put our, let's see, does that go on the inside? Yep. Need to put this guy back on. Well, I'm going to have to get all my tools ready here. Hopefully we can get our fan to kick in again. There's that going, sort of. There. And that one. Now that we have the Bowden tube out, it would be a good time to check the end of it. They will wear because you're printing with PLA, you're not printing terribly close to their deflection temperature or anything. But if you start printing PETG, ABS, other materials, then you want to check this to make sure you've not got problems in here. And you'll be able to see they physically look burnt-ish or worn, and this one looks fine. The other thing you want to make sure is that the end here is cut pretty much perpendicular to this axis so that you don't have a gap when you put it in there. There we go. I saw a chat, what are signs of a bad nozzle? There we go, got it to kick back in. So the nozzle being bad usually shows up as it's worn, right? So you're going to get these uneven lines because the nozzle is, maybe it's not round anymore, or at least if it's round, it's larger than it was at 0.4 millimeters. So it's going to look kind of blobby on the surface. Your surface finish just won't come out right because you're expecting a 0.4 millimeter strand of filament to come out, but you're getting maybe a 0.5 or 0.6 millimeter out, but you're not feeding in that much material, so it's going to be blobby. It'll build up a little bit of back pressure and then squirt it all out, and there's going to be blobs or gaps in your prints, and they're going to be on the surface of the print. The surface of your print is going to degrade over time. Now, if you just print PLA on a brass nozzle, it's going to be, depending on how much you print, do you print once a day, or do you print, 10 times a day, or once a week, or once a month, then it's going to obviously change. But typical brass nozzle is going to last you months and months under normal usage, and even a month under heavy usage. And under light usage, print once a week, then they might last a year, or you might never have to replace them. But the sign will be that your surface finish is suddenly bad on your print, and you haven't changed anything. You haven't done anything to change your flow rate or anything like that, but the print surface becomes bad. Now that we have changed from brass to steel, we do need to do a new PID tuning. Now we have to do one anyway because we changed out the firmware, but we are certainly going to have different responses from, I forgot to put this on there. Let's cool that off before I do that. We're going to have different responses from this thing heating up the steel nozzle from where it was heating up the brass nozzle. So I am going to have to do a PID tune. I won't do that today, but and these things are actually helpful too. I'm going to wait to put that back on there because it's probably quite warm. Maybe I can get it to snap on there. Yeah, I think I got it on there. Some of them fit better than others. This one actually fits pretty well. So we will need to do PID tuning. All right, let's go back over, well, not there. Let's go back to there. Here is our successful build after our failed build. And this little folder right here contains the file that we need, the firmware. So I clicked on it and it's opening somewhere in the background. Eventually it'll pop up here somewhere. Where did it go? Well, it's on the bottom of the screen. All right. So, well, actually, this is the SD card. So you can kind of see what I did here. Here is the unified firmware. I changed that extension from BIN to BAK, so just like a backup file, so that I still have these. These will never load again unless I change their name. Actually, I did change their name because I added this unified firmware, and here's the older Marlin that I have on this printer. So I just keep them on here, or keep them handy, because I know they work. And if I ever need to go back to one of these, I can change this extension to BIN and then give it some new number here so that it will recognize that this is a file it hasn't ever installed before, and reinstall these. So I know that these two will work, because it is totally possible that you edit something in the configuration file or the configuration advanced file that makes your printer not work, and you need a you know, you need to go back a version or whatever. So save your firmware that you know works. Give it a BAK extension or something. It doesn't have to be BAK. I just use that to mean kind of like backup, and that way it won't accidentally get installed on some printer. You put this SD card in another printer and it's never seen that firmware and it suddenly installs it. So it's still there on your SD card, but it's not going to be installed automatically. So I need to find where my, oh, it's opened like 3 of them. Here they are. So here is the firmware we just created at 8:30 on June 14th. And I'm going to copy this guy into here. So now this is a firmware name that this printer has never seen. It has the binary extension file that it's going to look for to say, hey, I should install that. And so now when we put this SD card in our printer, it should load it up. So I'm going to eject this guy, put it in there, and see if it actually works. Turn the printer off. Put our SD card in. This is very difficult for me to put in down there. Turn it on. We got the blue screen, which is good. That means it's doing something, and hopefully after 5-10 seconds it actually gets installed, and we have Marlin. We're on Marlin bug fix 2.0.x. We want to reset our EEPROM, and now we've got our printer back running, and it has the it should have the 5-point mesh leveling. So I don't know if I want to go through that whole process again, because it does, you know, it's kind of lengthy, but I will show you one thing you can do. So if you go, well, let's see, we can probably do that on here. It just won't give, it'll give us a bunch of zeros, but so there's no data on here now. But if we get our, let's get the prompter face running again. Let me find prompter face. I did see in Discord and got a couple of emails that people were having trouble running prompter face. I don't know why. It could be that you've never installed Python on your printer possibly, and so or on your computer, and maybe it just can't run without that already installed. But I thought the version that you download from Print Run or pronterface.com, whatever, or .org, had all the dependencies built into it, but I don't know. Remember, there is the issue that if you have Cura or Prusa or one of the other slicers open and you plug your USB cable in, that slicer is going to take over your printer communication, and Print Run or Pronterface won't be able to talk to it. So right now I don't have any of those open. I know I'm not on COM1. I don't know, I think I was on 3 last time. Nope. Try 9. Alright, it was 9. So after you've done the mesh leveling, so after you've done the mesh leveling on your printer and you've gone and probed all the points, then you can do G29 in your terminal. I did try this in the Cura terminal, and Cura, I don't know how it gives you any verbose data back. So it does the commands, but you don't get the data back. But G29, if I send that, well, so it says mesh bed leveling has no data. So what it would give you if you had gone through the mesh bed leveling process on your printer is it would give you a matrix, like an Excel sheet, of all these 5 points and how far above or below the average they are. Then you can go to a website or Excel or wherever, like this one. Let's see. Not this one. This one. You can go to, this is lockspace.eu 3D printer auto bed leveling mesh visualizer. Let me see if I can get that on the screen. There it is. This. You can go to this is the one I use. There are probably others. You can cut and paste. So you can go to print run, or not print run, printer face. The data will be here. You can Control C to copy, and then you can paste it in over the data that's already in that. This is the bed. The last time I did that, this is this printer's bed, and you can kind of see, then you visualize, and it gives you a little map. Now it's exaggerated. This whole thing, you know, there's 0 and there's 1. That's millimeters. So this has, it puts the lowest point at 0. Oh no, it didn't. The lowest point is actually slightly below 0 for this one. I had to drop down a little bit from the 0 home. I said the average earlier, but it's actually from the where you homed Z at. Now I have suspicions because these red spikes, they're not, you know, they're fractions of a millimeter above the others, but they're also in the exact locations that I have these binder clips. So there's a binder clip here, and there's a binder clip right at the middle at the back. Those are also correspond to the peaks. Now this one, there's not a peak corresponding peak with this one, but the other two, they do have peaks there. So I don't know if the binder clips themselves may be affecting the bed level. It's possible, because I have a rigid surface. You know, this surface that I've kind of clipped on here is rigid, and so it could be influencing the bed level a little bit. When you do this, when you do the bed mesh leveling, part of that routine doesn't heat the bed. So you need to go ahead and heat the bed, and maybe even the nozzle. The nozzle will change dimensions slightly, but not like the bed will. The bed will actually go through a whole different shape when you heat it up to different temperatures. So heat the bed to the temperature you plan to print at, then do the mesh data collection. Otherwise, you'll level it to one temperature, then you'll heat it up and it changes shape, and your level is completely out of whack then. So heat the bed first. All right, so I'm gonna go with what we've got right now, and let's try to print something with this material. So let's just, I don't know if y'all have ever used, I know a lot of you have used SolidWorks, and that's totally fine to use. There's nothing at all wrong with SolidWorks. In fact, you might be wondering what's going to happen when you get out of school and you don't have a SolidWorks license anymore. SolidWorks recently, like 4 months ago or less, introduced a version that is for hobbyist type, kind of like Fusion 360 has. Now it is pay, but it's like $60 or $90, so it's not very expensive. So you can get a hobby consumer level version of SolidWorks. I'm sure it doesn't have all the features that the full-blown thing has. I haven't used it, but you do have that option of using SolidWorks at a hobby level for pretty cheap price compared to what it would normally be. But what I was going to say is, I don't always like firing up SolidWorks to make some simple little part. In that case, I go to Tinkercad, and this doesn't even run locally. It's running in the browser. So I'm going to create a new design. You do have to have an account for this, but it's a free account. It's an Autodesk account. It's not cost you anything. But it's not a modeler like SolidWorks or even Fusion 360. It is a kind of additive thing. You've got all these primitive shapes over here, and you plop them down, and you can, you know, drag them. You can put dimensions on them. I'm going to make a little piece here just so we can see how rigid this part is going to be. And it doesn't take very long to print. So no, let's make it thinner than that. Let's do 3 millimeters. These are millimeters, by the way. Maybe I want it a little longer than 40. Let's do 50. So 50 by 10 by 3 millimeter part rectangle, and then I can export it as an STL. How about we heat up our nozzle and print this in PLA first, since I've got some right here. And then we will print it in the glass fiber stuff and see if there's any difference. I need Cura. So I like Tinkercad for making just little quick pieces or modifying parts. So like this thing, I haven't pointed this out, but on the printer, mine anyway, has an open fan slot here that stuff can easily, in fact that nozzle, if it had been any smaller, would have fallen in here when I dropped it. It was sitting on top of here. But little junk like this or whatever can easily fall down in here. And so it's a good idea to print some sort of cover. Now I printed this one, and it's a slightly bit too tall for how tight I've got the bed tightened down. Well, not for how long the screws are, rather. How long the screws are that are holding the bed down. And it needs to be a little bit shorter, or I need to shorten these screws. They're way too long. But what I was going to say is I used the Tinkercad to emboss my name on it really easily. So you can take existing models. I got the model from Thingiverse, and then you can import them to Tinkercad and modify them there way faster than you can, you know, changing it out in SolidWorks or Fusion 360. It's just a easy tool to do simple things in. All right, are we heated up? I need to heat up so I can load. Yeah, we're close enough. I need to load our filament back. When you're loading filament, if you will cut a sharp angle on here, then it makes it a little simpler to get it through some of the loading pieces up here. A lot of times, without that sharp angle, it'll get hung on the edge of the Bowden tube. All right, there's that. Cura is open over here. Not there, there. Let's load up our frantic Crittenden. And we're at a 0.28 millimeter. That's fine. Except that this one does have the mesh data. I'm going to comment, or I'm just going to erase this. This is how the M420 S1 turns on the mesh data for the bed level. Since this one has no data, I don't want this line in here. So I am going to remove this line, or I'm going to comment it out anyway, so that it's not active. Let's see. Let's slice this thing up. 11 minutes. We'll run out of time. Let's see if we can print it any faster. We could probably do without a brim. So let's do a skirt so we can see, you know, get the level right. But we'll do without a brim. And we're already printing. How fast are we printing? 50. Let's go up to 60 a little bit. Let's drop our infill down to 10. Let's do the grid infill. See if we can get any faster. 8 minutes. That might work. All right. Well, we need to save that on our SD card. What was it called? Some weird name. Frantic Crittenden. That's the thing about Tinkercad, is it makes up a name. You can overwrite it, but it makes up a random word name. Okay, whoops. There. Let us print from media, that thing. Print. Now, it could be bad because, it could be a bad print because we haven't done the PID tuning with the new nozzle. It has no bed level mesh in there, so, but we do have baby stepping, so maybe we can adjust for it. If our, sometimes with these nozzles, not these nozzles, with these LCD screens, they will freeze during a print. The screen will, the print will keep going, but the screen will freeze. I haven't tracked down what causes that, and it seems to be random. But if it freezes, then I won't be able to do the baby stepping if we need to. I'll try to do it even if we don't need to, just to show you kind of what it does. Oh, this still has our kind of weird purge line at the beginning too. So I think I still have that built into this Cura profile. I'm gonna see if I can get the filament. Yeah. Here goes our crazy fan not acting right. Once this starts, I'll go back to Cura and set it up for printing our polyamide nylon. And then we'll be like, we might be a few minutes over on class today, depending on how close this thing actually prints to 8 minutes. Oh, my screen did freeze, so I won't be able to do the baby stepping part. But it's actually a little tight. Let's tighten this down a little bit. Otherwise it might stick so much that we won't get it off of there. So all I'm doing is I'm manually tightening these screws on each corner to lower the bed, and watching this to, I don't want it transparent on there. You can even see on the screen, I think, how transparent the lines originally looked. If you get them too transparent like that, they'll not only stick really badly, but they will deform. They'll be squished so much that you'll have what's called elephant's foot, where the bottom kind of flares out and it won't be the right dimensions. So I'm just trying to reduce it a little bit. I wish our fan would kick in a little better there. It still is, I don't know. That fan, if this fan continues to not push enough air through here, then we could get heat creep into the heat sink, which will cause jams and clogs on us. All right, so let's go back. It is printing though. Let's go back to Cura and let's set this stuff up for this. So it says hot end temperature 220 to 250, bed temperature under 40, glue stick for adhesion. So I like to kind of split the middle of these recommended temperatures. So let's go to 235. You can build material profiles in here, but I usually just edit them. It said under 40, so let's do 35 on the build plate. Let's slow down a little bit. Typically, let's see if it says anything about printing speed. Doesn't say anything about printing speed. So let's keep the speed the same. If you find that if you're printing, like live print, then, oh, my window unfroze. My monitor did on the printer. You can tune the print, and there's a FR feed rate, and it might just be called rate on your menu. You can actually drop that thing down, and all of your speeds and feeds will drop by whatever percentage. So it's 100%. The 100 is the number to start with. That means 100% of whatever you set in the slicer. And you can speed everything up, or you can slow everything down. So if you get in the middle of a print and things, you know, it's printing too fast, or maybe you think you can print faster, you can tune it with that feed rate, and all of your feeds and speeds will increase. So it'll send stepper signals faster, and that's a way that you can adjust print speeds during the print itself. So that's in the menu on the printer. I'll leave it, since I printed the PLA at 60, I'll leave this one at 60. We'll leave the same infill for sure, because we want to see if there's any noticeable difference in strength here. And we'll leave. I could have reduced the top layers and bottom layers and saved us a little bit of time probably, but since I printed the PLA, it wouldn't be fair comparison if I changed them in any way, unless I reduced them and it was still as strong. So we could have probably saved some time with 2 walls, 2 top layers, 2 bottom layers, but we'll be all right. So I think we'll leave it like this and slice this guy. And see, you can also change printing temperature during the print. There's several tuning menus, so if you click the LCD button during the print, if you click the LCD button, there is a tune menu, and you can change speed. So speed is what it means by feed rate on this particular menu. Bed Z, so you can raise and lower the nozzle. You can change the nozzle temperature, and you can change the fan speed, bed temperature, flow rate, and there's that baby stepping option. So I don't want to change any of them right now, but you can change them. For some reason, while printing, this version of Marlin combined with this setup makes the LCD really slow to respond. We're going to change that at some point also. Now, one thing about these little sample rolls, when you undo them, they have a tendency to get all tangled up. So what I normally do is I take an old roll. This is another sample set with recycled PETG, and I spool them onto an older roll. But it takes a while, and I don't want to do that for just this little print. So we're just going to let this one be, and hopefully it doesn't make a giant mess when we unfurl it. In fact, I don't even. I'll just set it on the table over here because it's not going to use a lot of filament, and we'll be able to repair it. A lot of times, nylon can absorb moisture, and this has just been in this Ziploc with a little piece of desiccant, so I don't know how well it's going to print anyway, but we will find out. And we will put our glue stick down when we're almost ready with this print. It's doing the second top layer, and I told it to do 4 top layers, so it should be pretty soon. You might notice I still haven't put the magnetic bed on there. I didn't want to print this stuff on the bed, and you know, I've never printed with this, so it'll be. I was going to do it today during class just so you can see it, but we'll run out of time. So I'll keep pushing it down. Next time we'll put the magnetic bed on it. It doesn't take long. We're just going to run out of time. So that's the last set of walls, and there's should be the last top layer, unless I've lost count. Where's my scraper? All right, got my scraper ready. Oh, I mean, I must have lost count. Just doing one more layer. While that's doing that, here's another thing that we'll put on soon. I got it out. What this is, and you can print this particular piece. I've got to open it and then I'll show it to you. There are versions of this you can print, but this is a metal one. So it's going to be a pulley that goes, whoops, here in place of this one. It bolts in the same spot, and it has a thumb wheel where you can move that pulley in and out and tension this belt easier. Some of your printers come with that. You know, if you have the Max or version 2 or something, might have that already. But if you like that idea, they make metal ones for this axis and the y-axis, and it's not a bad thing to do. Also, if you don't want to pay money, you can print them. If you look on Thingiverse. All right, so there's, wow, that's, it delaminated inside as soon as I bent it. All right, let's do the nylon one. So I'm going to go ahead and set up preheat. Well, we'll preheat to ABS. It'll have to cool down a little bit though for that, because it's going to have a hotter temperature. No, that's going to heat the bed too much. And it wanted the bed much lower for some reason. All right, got to put our sliced file on our SD card. We've got to unload this material. And then we've got to put our, oh, when you undo a roll, be sure to do something like this. Otherwise, you'll come back and that roll will be very messy, more than likely. And it's a pain to re-spool one of those things. There are, I don't know, a lot. There's a lot of filament length that if you have to re-spool it. All right, so here's this thing. This one it's not too springy, so it's not going to go very far on us. I want to sharpen our end. Load it in here. I'm going to push some of the PLA out. All right, so there you can see some of the new stuff coming out of there. Let us save our new file. Oh. Hopefully, I didn't change the name of it, so hopefully that will be okay. All right, print from media, print. Okay, it does have the right temperature on it. All right, the bed's still a little bit warmer than it's supposed to be. Oh, the glue stick. Oh no. We have time. If I can get the glue stick open. This glue stick is very gummy. We almost, I don't know what would have happened, but we almost didn't follow the instructions. It's coming out. Looks pretty good, actually. All right. It flows really well. This stuff, it said, and that's what it says. It says on here, nylon reinforced with glass fibers. I won't cover it up. Has improved well. All right. This is what it says. Has improved in mechanical strength, rigidity, modulus, etc., comparing to pure nylon filament. It didn't say, well, I assume that means it's stronger, more rigid, and improved modulus. I don't know if they mean that makes it more flexible or if it is more rigid. It says it's more rigid, so I guess that means it has a higher modulus of elasticity compared to pure nylon, which would make sense because it does have some size of glass fiber, chopped fiber in this stuff. Improved creep resistance, which that's good because PLA creep, remember, is when you have a load attached to something for an extended period of time, it will deform over time even if the load's not changing. It'll basically, the material flows. And so this has improved creep resistance, so it's not going to flow as badly. It has better fatigue resistance, better heat resistance, and the distortion temperature can be 120, and then the units here aren't right. So I don't know if I think that's 120 degrees. All the other units are in Celsius. If it has distortion temperature 120 Celsius. That's really good. That's impressive if that's true. I don't know if it is or not. It might be 120 degrees Fahrenheit, which is still really good for these plastics. It has excellent print performance, which I agree, it's printing really well. It prints smoothly with no edge warping, which again, so far, that's what it looks like. At first, when it was printing, I could hear a little bit of popping coming from here, which usually means it has moisture trapped in it. Kind of, if it has a Rice Krispie sound when it's printing, then it's probably got a little bit of moisture. In fact, I can still hear it every now and then. So what that means is that there probably is moisture in the filament, which it was just in a Ziploc bag, so that's, you know, it wasn't really sealed against the humidity. So it might do with drying, would help it a little bit first, although it's printing fine. It doesn't seem to be a problem, but that could be an issue with it. I'll show you my filament dryer sometime. I have the eSUN filament dryer, I think is what it is. And it can dry a roll of filament in a couple of hours. You can bake them. Just most ovens won't go down low enough to bake out the water, and not melt the spool or the filament or something like that. So unless you have like a little toaster oven, you kind of can't do that. You can also dry them just by dumping them in or submerging them in a bucket of desiccant. You might even be able to use rice as the desiccant. I don't know, I haven't tried that. It's a little lumpy compared to how well the PLA printed. I'll let it finish though to see for sure how it looks, and then we'll see how rigid it is. We did go over time, so you have to go, that's okay. It's about halfway finished printing, so there's another 4 or so minutes before it'll be finished. I'll let it finish, but we did go past time. If you need to go, that's fine. It'll be recorded. I will say, I couldn't find, like I said, I couldn't find the glass fiber EPA filament, but I did find a carbon fiber one, and it looked like it was the same base nylon, but instead of glass fibers, it had carbon fibers. So I kind of want to try that and get a roll of it. I didn't see the price of it. See if we can look that up while we're looking at this thing. There's nothing really to see on the print right now, so let's go over here. $35 for for half kilogram. So you'd have to be careful with some of the specialty filaments because a lot of times they don't come in full kilogram rolls. So it's $70 a kilogram, which is that's up there. But if it's a material you can actually use for parts and not just for prototypes, then it might be worth it. This is this one. This is just the nylon itself, so no filler at all, and it's not crazy. It's a kilogram for $33 off of Amazon. That's not bad. You can certainly get PLA filament for $20 or so for decent filament. So 33 is not terrible for a kilogram, but it's just the nylon. It doesn't have any reinforcement in it. But it is that same EPA, which is printing pretty well, and it should have the same heat deflection. So if you're trying to print some part that's going to have to deal with heat, PLA is just not going to handle it. PLA you can put it in hot water and it'll deform. So it's just not going to be able to do it. But this, if it can do 120 Celsius before heat deflection, that's really good. Even if it's 120 Fahrenheit. I wonder if it tells more details on here. No. Doesn't really say the heat deflection temperature on here. So I'll have to find out if that's 120 Fahrenheit or 120 Celsius, because the symbol is not given. It just says 120. But all the other numbers are in Celsius. So that's not a bad potential filament, but I want some of the fiber filled ones, which do seem to be about $70 for a kilogram. All right, we're getting close. We're on one of the top layers. At least not the first one. I think it's probably the third one. Yeah, I think this is the last top layer, and then we'll be able to see. So PLA, first of all, it delaminated inside. As soon as I did this, you could, well, there you can see it. It's delaminated right there at the end. We'll have to zoom in for you to actually see. Well, no, you can't. You can see it like that. So that delamination could be, you know, my temperatures aren't quite right. So whenever you have this kind of stuff, a lot of times, first of all, I have a really low infill percentage, so the infill almost does nothing for holding the layers together, because the infill is printed faster, and it just kind of, sometimes it depending on what pattern you use, it doesn't even print on top of the previous pattern. And now this one, it did do that, but so this is pretty much just the walls, and it delaminated pretty easily. So I'm either under extruding, which I could believe that I'm under extruding a little bit, or I'm printing too low of temperature, which I printed this at 200, I believe, so I might go up a little bit to get a little better layer adhesion. Let's see what this thing does. Alright, let's get that off of there before something bad happens. Oh wow, it's rubbery. It actually feels a lot like nylon. So hey, you got somebody from Turkey. Well, we're about to end the stream, but that's okay. It did delaminate also, same spot right there. So I'm probably printing a little bit too cold, but remember we just put the steel nozzle on there, and that's could have something to do with we're printing below what we actually need to be printing, and we're getting delamination. But it actually is kind of rubbery feeling. The PLA is more rigid, but this actually does feel like nylon, like a nylon belt, sort of. That's what it feels like. So I'm going to do some more tests with this. I've got a little bit of it, you know, a little bit. It changed color a little bit too from the bulk material, the filament material. It actually looks a little pink in person. And we'll see if we can print a little bit hotter, get our PID tune correct for the steel nozzle, because it's probably way off from what it needed to be. But I like this material. It is not a stiff material, though. It is actually pretty flexible, but that might be useful. And we'll print some different shapes too. It's interesting that it delaminated the exact, well, not quite the exact. This one's pretty close to the center, and this one's closer to the bottom. But they both did delaminate, which kind of makes me think I'm under extruding and printing a little bit cold. But it's cool material. And I might get some of the carbon fiber filled stuff just to try it out, because I do like this. The carbon fiber filled is black also. I guess the carbon fibers are black, so I don't know if they dye it or if it's the fibers themselves that are causing it to be black. But I like this. I like this material. I'm glad they sent it in the little packet. Let's see what else. Well, they sent this recycled PETG, and oh, well, here's a carbon fiber PETG. We could try that one now that we have the hardened nozzle in there. And then the glow-in-the-dark rainbow, which is also all these are abrasive materials pretty much. The PETG is not abrasive. It can print fine with a brass nozzle, but all these others you wouldn't get very far with the brass nozzle. It would last you know, a couple of prints. Particularly some of these are very abrasive. Glow-in-the-dark for some reason is really abrasive. You could print a roll of glow-in-the-dark and the nozzle would be ruined. But we've got our steel nozzle. All right, we went way over time. 10 minutes over, not way over. Next time what are we doing next time? I had planned to do some designing for FDM, like design practices. You know, what are different things that you can incorporate now that you have the ability to 3D print, but also the limitation of how things are 3D printed. So I'll talk about that some. Maybe we'll finally get our magnetic bed put on because we haven't done that. But if you have some other ideas, things that you'd rather do, let me know and we can work in some new things too. Probably should install this guy too since I have it. So next time we'll put the magnetic bed, this guy on, and then talk a little bit about designing for printing in FDM. And maybe I've done some more with getting our little nylon to print. I don't have a lot of it to print with, but I do like the material. So we'll see how it works. I will see you all Wednesday. We'll be back on Wednesday. All right.